we have a special guest today, Steph Sedgwick from EBUS Academy. And Steph is an educator who is looking for ways of what are sort of could best practices be in how you combine nature journaling with astronomical education. So I thought, first of all, Steph, welcome to our forum here.
Thank
And
you.
we've got a bunch of crazy brains in the room here who will be giving you their ideas. But I thought it might be useful for us just to start with, sort of give us the picture of the Academy, the audience that you're going to be working with, ideas that you've come up with so far, things that you're sort of excited about. What kind of sort of flesh out for us what this will be kind of looking like and what you're looking for as feedback from the Brain Trust here.
Okay. Thank you very much for the introduction. I'm Steph Sedgwick. I teach at EBUS Academy, which is a online school. We're fully online. We have students who are full-time EBUS students, so they do all of their courses with us. We also have some students that we call cross-enrolled, which means they take some of their courses at their home school, and then they'll pick up one or two with us if there's something that we can offer that they don't have at their home school, or if there's a scheduling conflict. We also have students who do high-level sports or acting and things like that, and they're not able to spend as much time in a regular school, so we're able to help them out, pick things up that way. I teach senior science. I teach science 10, chemistry 11, physics 11 and 12, and I also teach in astronomy 12. And so at the moment, I'm working on a project to put into my astronomy 12 course that has to do with nature journaling. I'm also looking at building an environmental science 11 and 12 course for our school, which I want to do with nature journaling as well, but I figured I'd start with a project and see how that goes, and then work that in later. So our students are across the province. We deal with kids everywhere from the big city, Vancouver, Richmond, area, all the way up to the country. It could be the middle of nowhere, or we even have a few students up in the Yukon. So we have a very large area that we cover. My astronomy course is fairly small enrollment at the moment, but that's okay. I'd still like to be able to do this with a number of kids. We are continuous enrollment and asynchronous. And what that means is you can start a course at any time of the year. It doesn't mean you start right in September and you finish in June or December. You can pick up a course at any point throughout the year. So I could have kids who are at the beginning of the course. I could have kids who are at the end of the course. So they aren't necessarily at the same place. So having to do a nature journaling activity on one particular night might not work for everybody because there are different places in the course. Also, it might not fit with their schedule with other things that they have to do in the evenings. So I thought about doing it as an optional assignment to start with, and then giving students some choice as to which of the nature journaling activities they wanted to do. And then I was thinking about maybe 5 nature journaling activities that they're going to do that they choose, and then think of some way of putting that all together and some sort of culminating project where they can share what they learned by doing their nature journaling. I like the discussion questions in the How to Teach Nature Journaling book. I just find it difficult to do a discussion when I have kids who aren't necessarily doing the assignment on the same day or even the same week or month. I could put in a discussion forum in my course, but then I might have somebody who writes in some answers, but then the next person doesn't make a comment on those for a month or two. And that's not really the feedback that I'm hoping to give my students. So I need to try and think of another way to get them asking those questions or thinking about those ideas, and then put it together more on their own as a culminating project. So that's what I've been looking at. I can show you some of the activities I had in mind. I think it's that one. And Jack, I borrowed a picture from your nature journal.
Everything that I do is open source, so feel free to just anything that you like that you can use.
Okay. I'm also trying to get the idea across that you don't have to be an artist, because I don't want them to back out of that idea, of the idea of nature journaling because of that. And I think astronomy is actually a really good way to do that, because most of what we're looking at are circles. So even I can draw a circle. So,
or get a template, right?
Yeah. So some of the activities that I've got, can you see this screen?
Yes, we can.
Okay. So some of the activities, I was thinking that they do a total of 5 throughout the course, and that if possible that they could pick one from each of the different categories. So in terms of the sun, so location of the sun at sunrise or sunset, doesn't matter, over time. So that would be doing an east or west horizon, with obviously going further north and south of that, and then marking out where the sun rises once a week or once every 2 weeks or something like that over time. The height of the sun at noon over time. So how high does it get? You're probably not doing the course in July, but how high does it get in June? How high does it get in December? That sort of thing. And then doing some solstice observations, I think was related to Jack, some of the things that you've done before with solstice. So I was going to do that. You can tell my video explanations are not done yet, but I'm getting there. For the moon, the angle between the Earth, moon, and sun, 4 different phases. This one is something that I heard about doing another Pro D session, where you actually standing outside during the daytime, or right at sunset or something like that, and you point with one hand, you point to where the moon is, and you point with the other hand to where the sun is, and then that angle, is it a acute angle, is it obtuse angle, is it 180 degrees, and that then to relate that back to the actual drawing of where the Earth, sun, and moon are at the different phases. So it's just a way of getting students to think about, okay, well, quarter moon, I'm at 90 degrees, full moon, I'm 180 degrees, crescent is going to be a small angle, and it was just going to be a large angle. So just a way of mapping that out in their heads a bit better. Angle of the moon relative to the horizon, so that works better with a crescent moon, but just seeing how it comes up, doesn't always come up at the same angle. And then when can you see the moon during the daytime? What phases of the moon? Eclipse, if you happen to have a partial or total lunar eclipse during your course, then that would be a good one to look at. And then details of the moon, if you have something like a spotting scope or something to look at the moon, what details can you see on the moon? The stars one, I have, what have I got here? Indicator stars. So depending on where you live, what stars can you see? What are the ones that first come out in the night sky that you can see? Like for me, this time of year, Sirius is obviously one of the first ones, and then pretty much a lot of Orion is coming up. So what can you see, and how many more can you see as it gets darker and darker? Stars in relation. So basically the constellations, how are they mapped out towards each other or with each other? circumpolar stars over one night, so watching them rotate around the North Pole, and non-circumpolar stars throughout the season. So either where they rise every night, or which ones you can see at different seasons and things like that, or non-circumpolar stars over one night, so watching where does Orion come up, where does it set, that sort of thing. And then some general ones that I was thinking of is just the sit spot activity, go outside, what can you see? And what I was calling here an astronomy biodiversity, because there's more than just stars in the sky. So what sort of things can you see? Did you see any meteors? Did you see the northern lights? Did you see an airplane? What else did you happen to see up in the sky? So that's something. And then for planets, I just had a couple of ideas. Move into the planets over the sky or across the sky over time. And I was thinking to give them a sky chart, and then they could just plot out where it was rather than having them draw their own, which would be a little less accurate and would probably turn some of them off if they had to do their own. And then if you have a magnifier, then you could look at phases of Venus or moons of Jupiter as well. So those are possible activities. And like I said, I was thinking of having students do 5 over the course of one semester or over the course of the course, however long it took them to do that. And then just how to bring that all back together is what I need help with.
Right. Well, you're off to a great start here. There are some really terrific activities on here. Maybe let's just start by kind of tossing some of these around and thinking about them and how we can kind of get the most help our kids kind of get the most out of them. Why don't we minimize this screen?
Do you want me to stop sharing or?
Yeah, let's
Okay.
yeah, there we go. So you are off to a great start. So something that I think is interesting about this. So you are an online program, and
Yeah.
normally being an online program, there are disadvantages. You're not in this room together, and you also can be asynchronous, right?
Yeah.
And um, and your students are going to be in different places. So normally it's everybody like, look at this redwood tree. But if people don't have that redwood tree in front of you, you've all got different phenomena. Something that is interesting that you can actually do here with your online program, thinking that you have the opportunity for everybody to actually be looking at the same phenomenon and be aware that we're looking at that same phenomenon from different perspectives.
Yeah.
So one person's angle in the sky at one latitude is going to be different than another student's angle in the sky at another latitude, and you want to capitalize on that. I've got 2 questions about the structure of your program before we kind of launch into that.
Okay.
Are your students only in Canada, or are your online students all over the world?
They have to have an address in BC, but they don't have to actually physically be there.
All right.
We do have students who travel.
The more that are traveling, the better, because
Yeah.
then that just gives you more on any one phenomenon, the more different kind of ways people could be looking at that. At any one time, how many students are going to be taking the class at the same time?
I currently have 10 enrolled in Astronomy 12 at the moment. So
Okay.
that's not a lot, but
And they have the capacity to communicate with each other and to share information with each other.
they have that capacity. Not many of them do it, but they do have the capacity to do it.
All right. Why don't we just kind of go through these sort of phenomena categories? We talk about them a little bit, then we're going to throw it open to anybody else who's got ideas on that. And then we'll jump to the next one. Does that sound good to you?
Yep.
Right. Let's start with the moon. Let's talk moon activities, because the moon is such an amazing phenomenon up there, doing all sorts of interesting things. Um, you've got you've got the changes in phases. You've got the changes in the position of it. You've got its height in the sky throughout the year. All these different things. I want to take you over to a moon study that I was doing with a group of students at my daughter's school. So this
Okay.
is a class that is taught during the day. And what we did is, hold on, move the taxes. It's that time of year down here in the United States. They're off the desk here. And let's see if I can get my document camera to work. Yay! I love it when it works with the first button push. Moon, 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 moon. Oh, there's some moon. Right, so this page of chaos was moon observations with a group of students. And what we did is, this down here is a drawing of the front of the school. And later on, I was wishing that I made this smaller because I wanted to extend out this direction more. But after the full moon, what we did is, when school started in the morning, we went out. It's about 8 o'clock, and we drew a picture of where the moon was, sort of east to west, and how high it was in the sky in degrees. And we were using the one potato, two potato method of measuring degrees of arc in the sky. So I'm just taking my fist out at arm's length, putting the bottom of my fist on the horizon, then the next potato is on top of that. Each fist is 10 degrees. So there's 10, 20, 30 degrees, and figure out how high the moon was. And document camera. Moon, 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 moon. Come back, moon.
I thought I just saw it there closer to your other hand.
This side?
Yeah, that side. It was at the very end of where you were looking, I think. I could be wrong.
There's some eclipse. Aha, yes, you are right. Right, so this thing is starting to go across the sky, and as it does, each morning, it was a little bit higher in the sky, and it was further east. And as it's going, it's turning more and more sort of into the gibbous to about half moon, and then it is starting to turn crescent as it continues across the sky. So we saw it moving this way each day. And then we also went out, and the we looked at, on one day when it was sort of here in the middle, we saw that in the morning, and then we found that when we went out for recess, we saw that the moon was going in this direction back down here as the day went on. If we wait till it gets really crescenty, then you get to see it travel further, but it is much harder to find. So when it's about a half, you get to see it kind of track back this way. So the moon each day is moving this way, but when you come out at the same time on a bunch of days, you can see it jump to the left a little bit. And so the other thing that we did is we we tracked the sun over the course of the day. And actually we could do this in just sort of a matter of minutes. This morning I went out with that same group of students, and we wanted to review this data that they had taken in their journal. But because the teacher didn't have access to their sheets, we wanted to remind them of how the sun moved through the sky. And so what I did is there's a little column sticking up. There's for a sort of a traffic post. And we took a piece of chalk, we drew a line. Let's zoom down. We drew a line to the end of its shadow, and then we just kept talking for a little bit, and about 10 minutes later, the line was over here. It was shorter. And if you've done that sort of solstice equinox thing with us, you can do that throughout the day. But so they're able to see that this sun shadow is moving this way. So the sun shadow is moving to the right. And that means that the sun itself, as you look over the course of the day, is going, as it goes from the east to the west, it is moving to the right in the northern hemisphere, right? So then we went back inside, and here's where I had this idea of a sort of astronomy activity. And what we did is I got them in pairs, and you had one kid be the sun and the other kid be the earth. And what the earth kid does is the sun kid just has to stand there, right? And the earth kid spins. And what they would do is they want the sun person to move past them from the left to the right. Because remember, the sun is moving across the sky from east to west, from the left to the right, if you're in the northern hemisphere, right? So they have their left shoulder and their right shoulder, and what they would do is they would spin and say, like, okay, here's my right shoulder. If I'm spinning this way, it's my right shoulder and then my left. So we're moving from right to left if I'm spinning this way, right? And then we had them spin the other way, and they realized that I see you, now I see you, here's my left shoulder, left to right. Oh, right. So they were able to, on seeing that difference in the angle of which direction the sun was going, because the sun is going this way across the sky, they were able to figure out which way the Earth itself is spinning. And then we had this whole discussion about, you can look at phenomena and then use your brain in modeling. The just spinning around like this, that's the modeling. That's as simple as a model can be. Just it was more fun because we had some spinny chairs in the room, and if you get to spin on a spinny chair, that's even more fun. But so that was cool. And so something I think you might want to do in this program is to connect things that we know about space with how do we know that? What's the strength of the argument? What's the evidence for it? That is one of my favorite things about Carl Sagan's Cosmos program, because he didn't just say, like, let me tell you about novas and supernovas. He went into in depth about how this stuff was figured out and what is the evidence for it. So I think that's a great way to kind of connect those things. So that was the start of our program. And then we also had this moon moving across the sky. So the next thing I asked them is, the sun is moving from left to right. Each day when we get up, we see and the moon a little bit further to the left. How can we come up with a model to check this out? Is the moon going, as you're looking from a north polar projection, is the moon going clockwise or counterclockwise around the Earth? And it turns out that, and I told them, like, from the observations you've made, you're going to be able to figure this out. And so then what we did is we had the kids the kids got also in pairs. And I'm going to, let me make this screen big here for a second. Aha. All right. So this is one kid. And this is the other kid. Okay. You had one kid you would take turns. One kid's going to be the Earth, and the other kid is going to be the moon. And what we did is the Earth kid's job is to rotate like this. So the Earth kid is spinning. The moon kid is going to walk slowly in a circle around this. So if they actually were to model this exactly, this person would be spinning about 29 times every time this kid went around them, right? So the moon takes, what is it, about 29 days to get around? Is that right, Steph?
Yep.
Okay. So but they don't have to time it, but just that this person is going to be spinning more quickly than this person is going around. And what they did is they noticed, I'm going to imagine that this is like the front of their face. When they're facing here, they're noticing, where is this kid relative to them? And then they're spinning around while this kid is slowly moving, so that the next time they come around, they're noticing, is this person moving to the right?
Oh, Jack, I'm sorry to interrupt you, but I do have a question. How would one adapt this particular activity for if you aren't in a class setting, but if you're online and don't have necessarily another kid with you? Is there a way that you can do something similar, but in a different sort of setting?
So I was thinking about that. One, like, you could do this with your brother and sister. It doesn't have to be somebody else in the class, right? So you could grab another family member and do this experiment with them, and that makes it more interactive. The other thing you could do is you could just get two objects, and you can do this. So as you kind of come around here, as this person moves around, right, by the next time I see them, right?
I think it's still more it's much more powerful to be the Earth,
Yes,
right? And to be able to see it. We've used like just pictures of the sun, or pictures of, we had a person holding it, but you could just put a stationary object, label it the moon, and then still do the turning. And that you just have to have somebody who could help you move it.
So yeah, I agree with you that having this person here be able to see that from their perspective, this person is moving from the right to the left, right? And see, they're moving from the right to the left. If this person is going the opposite direction, you get the progression of these positions going the other way. And then from this, the kids can figure out, from a north polar projection, is the moon going that way or that way? So they were, from their own observations, able to figure out, and then explain to me why you say that. So they were able to figure out that even though you see this moon is progressing across the sky from right to left, we figured out, because the sun is going from left to right.
Oh, Jack, I'm sorry to interrupt you again.
We've got to zoom out. Okay.
Thank you.
like, so the sun is moving across this way, and that's evidence that the Earth is going counterclockwise. We see the moon progressing this way, and that at first the kids are thinking that means that the moon is going to be going clockwise. But once they do this activity, they realize that no, that's what happens if the moon is also going counterclockwise around the thing. So what I liked about this is that you started with these observations, and there's other cool things you can do from this, like the when does the new moon so you could kind of get into like, when do you see the new moon in the sky, when do you, or close to the crescent moons in the sky, what's their behavior, what's that going to be like with full moons. You get the behavior of these features. You can then get off the planet and figure out these things like the way that they're spinning. I want to bring Steph in. I'm going to add you into the spotlight. There we go. Wanted to get your thoughts and feedback about kind of going in this sort of a direction with your students, and how this might work in, or is this not the sort of thing you're looking for?
I hadn't thought about it, and I like it. Because honestly, talking about does the Earth spin clockwise or counterclockwise is not something I go into in my course. So for them to be able to figure that out, I think that would be really kind of cool. Most of my students would have at least one other person around that they could use as a buddy to do this, either a sibling or a parent or something. If they are, we do get adult students as well. So if they happen to be living on their own, well, maybe they can grab a friend for a minute and say, okay, we're going to figure this out together. So it should be possible to do that. And I like the idea of being able to see it with the people rather than the more abstract model on a piece of paper. So.
Yeah. I agree. Like being able to see, like, oh, you're moving to the right. I see you moving from the right, not having to, like, I'm going to try to get down there from the pencil's perspective. That's useful. Other things that I was thinking you might do with the kind of, if you have, what percentage of your students have magnification?
I don't actually know. I've never asked. So.
Okay. If they have, it'd be neat to get people to try to make their own moon map from their own direct observations. The problem is most people are probably just going to go online, pull up a picture of the moon,
yeah,
and just copy that. The something that I think might be fun to try to catch is the wobble in the moon, so that we see one face of the moon, but we actually, as that shadow is going across it, we actually get to see a little bit more than that, because on each side, like, it's going to show you a little bit. So the moon isn't doing this as it's kind of going across in front of us. It's doing this as it goes across. And so it's sometimes showing you a little bit of shoulder here, and then other times it's going like, right, a little bit of shoulder there. And so as it's a subtle thing, but it'd be interesting to see if students could pick that up at the one would be so you'd want to think of like when they would draw the rim on that side. So what you do, one would be kind of from a crescent on one side. But I have to kind of look into that more, like when would you kind of get people to kind of draw how much you can see? And then you'd also kind of look at how much you see at the full moon and then compare, and you'll realize that there are times that you can see a little bit more than that face that is facing you at the full. That might be interesting. Let's take this moon observation thing to the big group. And oh, here's one other thing that would be fun to do, because there's the moon illusion of it getting bigger. Is to ask them to come up with a way of accurately measuring the width of the moon. Not give them a method. Can they measure the width of the moon when it is close to the horizon and when it is high in the sky? And how would you go about measuring that to make the process of coming up with a measurement thing be something that they have to invent? Let's turn this over to the big crowd. Hey everybody. We are now looking for you to raise your hands and give us any other Moonly activities. What might we do with the moon to help students kind of make this connection between figuring stuff out, observing what is cool stuff to do with the moon? Are there any ideas in the and by the way, you guys can't let us down here, because I promised Steph that there's going to be a ton of ideas from all of you. So
Um,
there
also,
we
also too, after we see the hands, there's been a lot of really, really good ideas in the chat too.
Oh, okay. Let's start with that. We're going to first bring Laura Markham in.
Oh wait, but Billy Joe's raising her hand. Billy Joe.
Billy Joe, and then Laura. Billy Joe Reed. We're going to bring Billy Joe in. There we go. Hey there.
Hey, I'm not sure if this is like totally relevant, but I always think like how to connect things together. And so, there's lots of ways I think that you had about like measuring the moon and mapping the moon. But in terms of observation, like I wonder if you were to ask the students like on a crescent moon when they go outside and they're sort of looking at that, like what observations or impacts are they seeing on birds and wildlife that are in the area as opposed to a full moon, right? And so looking at sort of how that moon is affecting behavior on what's happening in and around them, and especially if they're so I'm from Ontario as well, so like fellow Canadian. But if you've got folks that are in northern BC or even in the Yukon, you said, or further down in BC, like it's going to be quite different, the habitats. And then you have the tides as well, right? So we know that the moon has a pull on the tides, but what kind of observations are they making? And then those can be similar or quite different, especially if they're traveling. And so what's happening with birds specifically, and then some of your wildlife? Are you hearing more birds, seeing more birds when it's a full bright sky and you can see the moon and all the stars? What is the difference in when there's cloud cover? All these sorts of different things that I think would be really interesting to connect it from above and what the impact is below as well. So it could be interesting and come up with some really cool questions, especially at a grade 12 level. Some higher thinking there on what's kind of going on. So just a thought.
Oh, I like those ideas of sort of bringing in these other observations. Billy Joe, what kind of natural history observations do you think people ought to be focusing on?
I don't know. I was just thinking, like, as she was going through the the web page there, I was just thinking, like, I wonder what is going on, because I know that, like, when you're with students, teachers and stuff, I always say, "Oh, it must be a full moon. The kids are all wild and crazy." So I just wonder, like, do the birds go into a bit of a different frenzy? Do the animals out and being sort of active? Like, what is that sort of impact? And is there an impact? And is there any observations that you can make within your area? And I think that you could be doing that potentially. I think one of your things was to find a sit spot to watch the sky. And if you're already mapping the moon at different variables, then I think it would be easy to add in the different things that you're noticing that is going on around you with the wildlife, right? what is happening. So are the birds more active during a full moon? Are they less active during a crescent moon? And what are you observing? What sounds are you hearing? And why might this be happening, right? So is there something else out there with that moon pull that we don't actually have scientific knowledge about at this moment, but is there some observations that we can make about it? I don't know. I think it'd be interesting.
This also makes me think of kind of an interesting human psychological thing that you could do.
Yeah.
Because we have our lore is filled with stories of the moons making people crazy. The term lunatic actually comes from that the moon makes you crazy. If you'll hear that people say that, you know, ER rooms are more busy during full moons. And the interesting question is that true?
Is it? I don't know. I also know that
it turns out it ends up, so people have actually researched this. And what you want is an objective thing of, like, if it turns out if you go and you ask people in ERs, is it more busy during a full moon? They'll say yes. Because they've heard that. And then on some nights where it's crazy busy, they take their break and they step outside and they kind of look like, yep, it's a full moon. But when it's not, they don't notice it because it's a non-event.
So the other interesting thing too that made me think about this is I have a friend who works she does some stuff with like herbs, and because we all have like parasites that live within our system, right? And so sometimes that system in our intestines and stuff can kind of get overloaded with different parasites. And so you can do actually something that's called a moon cleanse, and they actually tell you to do this cleanse, like, you know, during the moon, because they say that the parasites are more active. I don't know if that's true or not. I don't know. I'm just saying it's interesting, as that it could be something that our species more active at these times. I don't know, but it's interesting. That's all I'm going to say. I don't know yes or no if that's true or not, but it's interesting.
I'd say I can't say for all of it, but the bulk of all this cleanse stuff is pseudoscience, woo, made up things.
Totally. I was just more thinking
will
like,
swear by it because, again, confirmation bias is there. Right?
Yeah. But I was just more thinking like, do things move more during the full moon, right? So take all of the other stuff out of it. Are things more active during that? And if you're in that sit spot, can you be listening to the birds? Can you be looking for the wildlife in that sit spot? And are you noticing a trend if you are doing this more than once? That's all.
I would wonder about, because the danger, of course, is confirmation bias.
Yeah.
And a small sample size.
Yeah.
Susan, I'm looking at you, right? So one way of getting around that is if you can get access to some sort of a data set and correlate that against the moon.
But could that data set be all the different students that are in the class that are doing the same thing and seeing what their observations are and having an interesting conversation about it?
You would want to have the collection of the data be decoupled from them thinking about the moon.
Right.
So that's why something like ER admissions is a nice sort of independent data set. But if you're telling somebody, I want you to take this pill and notice what it does to your respiratory rate. Right?
Yeah, but I wouldn't tell them. I would just say, make the observations of what you see. You just don't give them that information. You don't tell them that you're wanting them to see if there is a difference about the moon, because she was saying you want them just to make observations. So all you're asking them to do is to make observations. If a trend comes out, then a trend comes out. But it's the way that you set it up. If you set it up as in that way, then you're already putting that bias into their mind. But if you don't set it up and you're just saying, in addition to tracking the moon, in addition to calculating the height, in addition, I want you to make some general observations about what is going on and what you are seeing in the area as you are tracking this moon for that 29-day cycle.
Yeah.
Could be. Who knows?
Yes.
Just
Yeah.
right. Bring Laura and Susan in as well.
And I think that Susan has something to talk, probably is going to be addressing some of the statistics behind this.
Yeah, totally.
Laura, let's bring Susan in first. And Laura, we're not disrespecting you, we're not forgetting you, but I'm thinking that what Susan's thoughts are going to be doing is going to tie in specifically to this. And then we're going to jump to you, and you're in the queue.
Yes, but I can't put Laura on a spotlight unless she is able to turn her camera on. So she might just have to talk out loud. That was the only thing I was going to say.
No worries. Hi there. So Steph,
Hi there.
Susan is our resident mathematician, and the person that I call up actually just the other day when I had statistics questions.
Send up the stats signal and I will be there.
That's right. So
I was going to say, I had raised my hand for an entirely different thought.
Oh no! Oh, so Steph, I mean, sorry, Laura, I'm so sorry about that.
No, that's right. But I was going to say it would be nice if I could sort of jump in to confirm your bias there with that. But I agree. This is, you know, a lot of these things. If we're starting to try to collect data about things that have some randomness to it, randomness in this case really being another word for unpredictability. So things like, you know, what are the critters doing? You know, are they moving more? Are they doing more things? Are they doing less things? You know, is influenced by so many factors that's where having a large sample size and doing appropriate statistics with your data is useful. What statistics you do, I think, depends on what data you're collecting. But yes. So anyway, so yes, I think that these are great thoughts. I didn't actually have anything special to add to that. So sorry to disappoint you. But yeah, no, I think it's great. I was actually, I raised my hand because I was thinking going down a totally different rabbit hole that I went down just recently, and I thought, I don't know if this goes in the direction that you would be interested in or would be practical to work on, but this was the rabbit hole that I went down a few days ago, and then it just sort of brought it all back to me right now, was this sort of observation of what shape do you see when you look at a crescent moon, or a gibbous moon for that matter, but really a crescent moon was what I was thinking of, because I was thinking about how we often depict the moon or the crescent moon in art throughout history and so on, and we often depict it looking like this, right? You'll often see it in art. You'll see this thing that has the horns of the crescent coming really, really big around and pointing. And so it might be an interesting question to ask students to pay attention to the precise shape that you're seeing. How far around the circle do the points, the horns of the crescent go when you're seeing a crescent moon? Do they go most of the way around? If you fill out the circle that they're making, where do those points end? Do they end at different places when the crescent is more closer to half moon or closer to new moon? And so in geometry, this is the rabbit hole I went down, because Wikipedia is great, let me tell you. All the math Wikipedia is awesome. In geometry, the shape that is a crescent is called a lune, which you might not be surprised by. If you look at where is that terminator line actually touching the edges of the moon? The whole way down from new to full and so on. Where are the ends of the terminator hitting the edge? It looks like they're both exactly 180 degrees opposite each other, no matter what phase the moon is in, right? If you made a line across those, you'd be making a line that was pretty much a diameter of the moon. Mm-hmm. And the shape of that the shape of where we're seeing the terminator, if you look very carefully at how straight it looks near the center of the moon, and how straight or curved it looks near the ends of the crescent, especially when you see something close to full like that. What you're seeing is you're seeing a shape that's not a circular arc, because it's more bent near the ends, that terminator curve there. Mm-hmm. And so the way that the moon is often depicted, and oftentimes you'll see sort of a circular arc with a circle chopped out of it. And maybe that circle's very big, maybe that circle's very small, and it makes a very pleasing shape that shows up in a lot of heraldry. It shows up in lots of art.
Flags, yeah.
Right. But what we're actually seeing, if we model the moon as a sphere, that terminator, which is the line between the light and shadow, is a great circle on the moon. So it's basically it's a circle that's the biggest circle you could make on that sphere. But we're seeing that great circle at some angle. I mean, we're seeing that great circle straight on if the moon is full or new. We're seeing it right like as a straight line segment if we have half moon. But if we see that at a different phase, that great circle is actually going to look like an ellipse. So actually what you want is, if I can find it here we go, is I've drawn the big, let me come back in here to red and do this. Hold on. Ignore my somewhat wonky moon circle here, but here we go. So in black, I have the moon as a circle with this sort of dotted line here.
Oh, that's a fun way to visualize.
But what you're seeing is the red is actually the circle that is the terminator. And when you see it in perspective like this, or you see it when it's tilted, it looks like an ellipse. And so ultimately, the horns of the crescent should always be diametrically opposed, no matter what phase you're looking at. It's hard to tell when it's close to new or close to full. But it's easier to tell when it's kind of in the middle. But so I think it would be an interesting question to investigate. And I don't know how practical this is, because like this is a great geometrical model. But now I'm thinking about, okay, if I'm actually looking at the moon, if I have that visualization that Jack just brought up, you can really, really see it. But if I'm looking at the moon, how well can I actually tell the shape of that? But it'd be interesting to draw and to see, like, if you draw the part of the moon you can see and you extend the rest of the outer edge out to a circle, where on that circle are you actually seeing the points of the crescent?
Mm-hmm.
And do those points change how far around the circle they are, depending on the phase? And I predict what you will see is they will not change how far around the circle they are, because they will always be diametrically opposed to each other. Yeah, so I don't know how practical it seems. That's going in a very different direction than a lot of this, but it's also interesting. It's interesting geometry involved in that. I was digging around, playing around with this question of, it turns out to be geometrically very difficult to compute the area of a loon. Oh. And there are 5 specific loons of proportions, and not all of them, well, in fact, none of them look like the crescent moon, because all of them are made with 2 circular arcs. But there are 5 specific loons of certain proportions that we can actually basically compute from the area with a ruler and compass construction, and the rest you can't. So interesting rabbit hole to go down. Again, maybe totally a separate question, from what you're looking at. But I think it'd be interesting to look at the shape is what I'm getting at. So.
Yeah. And this sort of reminds me of a just if an activity does involve drawing the moon, kind of a sort of related to what you're saying there, Susan, an approach that I found that is very helpful for that is to get people to first draw a circle, right, and then to figure out on that circle what is the axis of the tilt. So you then sort of figure out, like, is my moon, this way, and what I like to think
of, one thing Steph had mentioned, I think, looking at, right?
Yeah. If there's, like, say, a crescent, think of that as a dull arrow. Where is the shaft of that arrow? Right. So then what I do is I draw that angle in on my moon. Right. And then perpendicular to that, I'm going to put another one through which is going to give me the poles from which I am going to make my crescent. And so let's say I'm doing a crescent moon. It's going to go from one of those poles to the other. Or maybe it's a little bit further out. Or if it's a gibbous moon, you know, these you're going to come back to those points. So that gives you, that allows you to then draw the moon that you are seeing and get the angle. Need a Vea to help me find my my page.
You've been doing too much journaling.
Yeah, there we go. So I can figure out what is the tilt of it, and also get a kind of quick sketch of what the phase is going to be and have that be accurate.
And that is depending on that fact that no matter what phase the moon is in, that point where the terminator meets the outer edge of the moon is always going to happen along on that diameter that you've drawn.
Yeah. Yeah.
No matter what phase. Which interesting to know. I know you sort of suggested we get into eclipses later on, but I recall looking at that in the most recent the last lunar eclipse that I was looking at, that when you're seeing the shadow of the Earth go across the moon, that shape is not making the same kind of, it is always essentially a circular arc, not an elliptical, and it is not necessarily touching the edges of the outer edge of the moon diametrically across from each other. It might be less or more depending on when you are during that eclipse. So the shape that you see of the shadow of the Earth on the moon is totally different.
Right. Right.
Yeah. So anyway, yeah. So exploring that, investigating those shapes, it would be interesting to look at. And I'm trying to decide. I'm trying to think how difficult would it be to do that in a quantitative way versus more of a qualitative way when you are just looking at the moon and drawing that in your nature journal, without already having this model in mind of how you're going to draw the moon. But it's interesting to do. So.
Then we're getting into that difficult math that you were talking about.
It's all about spherical geometry.
Yeah,
it's fun.
Huh. Let's bring Laura in on this conversation as well. Laura, what does this get you thinking about? What do you think we might be doing in our journals here?
Well, let me just speak to that point right there. I think that, first let me say that I don't know that much about Canadian science standards. So where they are in terms of content, or they're looking at things that are equivalent to our science practices and cross-cutting concepts. But I think that with this age group, that having them involve their nature journal more, is maybe a little bit more of a science journal where they are doing some thinking about how can I systematically or set up a way to observe things where I'm keeping a lot of the things the same, but only changing a few different things, that kind of ideas, that is actually part of the learning. Being able to think about how am I going to collect my observations so that they are evident and they're not just random things. And so, in a nature field when you're doing field observations, right, you set things up so you can do systematic observations. So I'm thinking, so they would think about how they could do it, how they could take their information from one thing to, they might actually take it out of their journal and with their models. I think. Second thing, sorry, I'm just trying to remember all the things I was thinking about, was that, and I mentioned it, I think in the chat, was that I think modeling is incredibly powerful, and that they would want to record what they see when they do their modeling. and then compare it. And then that becomes more of the claim evidence kind of thing where you can say, you know, this is what I saw with this model, and not just verbalize it, but actually have sketched about what I see. Let's see. Oh, and there are some ways that you might be able to get them to places. You can use your arm as an astrolabe. I don't know if I missed that part, what you're talking about, Jack, in terms of how the kids in your daughter's class were able to, whether they used an astrolabe or how they figured out how high they were in the sky. But you can use it right to left and up and down, and to get more numbers to go with in your nature journal. And I have a pretty cool model that you can use to figure out the phases of the moon, which uses a ball that is half black and half white. So you have a half lit ball, and you can use yourself as the Earth and the observer on the Earth. And anyway, by moving it around, and holding it in a certain way, you can practice. You can mess around until you can figure out other things. You can see why the progression of the phases happens. But I think that would go really well after you figured out which way the moon was moving, which you could then put that information together with other information and be able to see the different phases at different times, and even figure out why it's in the sky in different places at different times of the day, at the same time of the day.
Yeah.
So I'm just looking at it more from a science teacher perspective, that you could, where is the nature journal in terms of your evidence, but also come back to it for your discussion of, and you have those things in the book, right? I mean, coming back to look at your model, coming back to sort of think out, I can compare this and this, and I can make some, draw some conclusions. Yeah. So that the nature journal doesn't have to be a whole bunch of brand new things, but it's a folding in of the nature journal into the types of observations you'd want them to be making.
So you're saying you'd like to see ways to use sort of astronomy related phenomena to give them the experience of kind of controlling variables and trying to figure out one thing. It's interesting. Sorry, what?
You've got all those phenomena, right? You've got the Earth and its rotation. You actually can do stuff. If you do it for long enough, you can do things by looking at the stars and to figure out the revolution. Right? I mean, that's how all the astronomers before us figured all this stuff out. It's systematically watching things and writing it down. And then, yes, they use math. But to be able to do that, and then I think that whole connection between observation and then modeling, well, let's try modeling it this way and that way, and try things, and which one gets us closer to what we're actually observing. So we have to observe carefully, so then you can observe in your model, and then you compare your model to your observations, and that gives you evidence that you figured something out. And that is part of, at least in the States, of the process that we're teaching kids in science. You know, that goes more to the science practices and some of the cross-cutting concepts, and not just content. And I really find the nature journal can be really intimately tied to that, because it's, you know, you don't have to call it a science journal. It's just a nature journal. When you use your nature journal with a little bit more specific intent. You're not just, I'm going out to observe. I'm going out to observe this, so that I can get make these observations, so that I can then think about them. It's just, it's a way of using it more systematically. And it's what I've always had to do when I had students use Nature Journal, is I couldn't just send them out. I mean, I do give them opportunities to do some, general observations, but we also little prompts, okay, today we've done things with the moon, but today we're going to look for different things with water, or because I haven't been successful with, let's look back at your observations and can you pull enough of the observations we want to talk about out from at least an individual person's. I think if you had a whole class, you could do that.
We're trying to get people to the point that they can think about, how can I set up a systematic observation to be able to reach some conclusion. This actually, I see, Avea, you've got your hands up. I want to say something that is specific to what Laura was talking about here. Is your thing tied into what Laura is saying, or is that a...
You should ask that first, because it's a bit different what I was going to ask.
Great. So, Laura, let me show you. This is a moon experiment that I am in the process of setting up that I think might meet some of the criteria that you're talking about. I have a friend who made an interesting claim. And this claim was that during the day, it is warm because the sun is out. During night, it is cold because the moon is out. And that it was the moon itself that was casting cold light. And I said to myself, we had this very interesting conversation. I don't, I don't think that things work that way. And then the question came up, and how do you know? So what I have done is I'm going to share, this is my experimental design for actually in a few days. What I'm going to do, hold on a second. There we go. I'm going to share this. This is my experimental design. At night, Avea, can you see a little drawing that I put up?
Yes.
Right. So this will be my experimental design. When the moon is out, I am going to, at night, on a still night with no wind and no cloud cover, and a full moon or close to full moon, I have prepared a set of 40 black colored tiles. And I'm going to place those on top of a pad of insulating foam. And I have made a cardboard moon blocker to block the moonlight. And then what I will do is measure the temperature using two types of thermometers. The temperatures of the tiles that are on the moonlight side and on the moon shadow side. And then I was just talking with Susan the other day about how would I statistically analyze this. And we had a really interesting conversation about that. But what I'm going to do then is I will have a set of data in moonlight and a set of data in moon shadow. And if either way that this comes out, one of us is going to be able to help clear up a misconception. Because either I've got a misconception about the way that heating and cooling happens, or my friend does. But this sort of experimental design, we think is going to help us be able to separate that out. And I'll be taking all my notes in my nature journal.
Yeah, that's cool. I do think, though, that it might be worthwhile for him to get a chance to observe that the moon is actually out in the day just as much as it is out as it is in the night.
That's right.
It's a smaller surface reflecting towards us during the day. I will grant you that. But that so learning a little bit about how the moon phases work might help clear the misconception too. But yeah, the fact that the moon is actually
Well,
12 hours, half of the time it's yeah.
But what I want to what we need to do is we need to go into
no, it's marvelous.
test like
I like
this
it.
in a way that
talked about the isolation. You thermally isolated it. You're blocking it. You've thought about controlling your variable. How could we do this? How could we do that? It's a lot of temperature measurements.
fun.
So, but yeah, I mean,
report back on what we discovered.
It's a good controlled experiment. It's not the way I would have gone originally. I would have gone, but then maybe I wouldn't have gotten very far with my argument. So if this is something that he sees as evidence, then and that's what he needs to be that first thing, then that's where you need to start, right? You have to start with what they agree is this is an observation. We are setting things up fairly. We are
right. We need to because otherwise, I mean, confirmation bias is the thing that comes and bites us all in the tail, right? If we think we know what is going on in this world, we will see that everywhere we turn, and the result is the perpetuation of pseudoscience, or just beliefs that that have no basis in evidence. So let's bring on the mad botanist and get some more thoughts on this. Thank you so much for your thoughts on that, Laura. You're again looking at how can we use phenomena in the sky as ways of to help us sort of think about setting up experiments and measuring things and testing things. I think that as science educators, that's really useful things, because very often, I think an important thing to be aware of is that we're trying to figure out, say, the birth of stars and stellar evolution by looking at all these things. You can't make a star happen and look at it over billions of years, right? You have to look around and try to piece a story together, and so there's different ways we have to sort of think about things. Sometimes we are inferring what is going on from the observations that we make. Vea, what does this get you thinking about?
Actually, my entire thing was that I know that we can get really, really excited about like all of the cool stuff in the sky, but I wanted to check in with Steph and see, like, because I know that we have all these ideas, but I wanted to know if we were focusing on what you wanted to focus on and what you'd wanted, like if there were things that we should be focusing on instead to help you with your program. And so I wanted to check in with you and see about that. And I also, yeah, so go, please, Steph.
I love all the ideas. I've made a couple notes here. I was hoping to talk about how to bring it all back together, though, and some sort of culminating activity. So if anyone has ideas on that, that would be wonderful.
Well, maybe tell us a little bit more about that. Sorry, Vea, you had your hand up.
Actually, no, I would like to hear Steph first. I was going to ask a question to follow up what you just said, but please.
So if I have my students do, say, 5 journaling activities throughout their time in my course, even if they are just more prescriptive, like I want you to go out and see this and notice that, because we don't have a lot of nature journaling in our program at the moment. So it would be something very new for them. So they might need a little more support, especially as they're doing it on their own. So how do I get them to take a look at what they've done and then bring it all together into, okay, this is a meaningful learning tool, and I've developed certain skills, and I like, how can I bring that all together?
Do you mind if I ask you some questions about that?
Sure.
So, are there any particular takeaway messages that you're wanting them to walk away with? It sounds like that the nature journaling is, is a good investigative tool. Are there any particular messages or takeaway messages about astrology that you're wanting them to, or astronomy rather, astronomy, that you're that you're wanting them to walk away with? Because that could help sort of figure out what we do, like with a culminating activity.
I think it kind of depends on which activity they're doing.
Hmm.
So if they were doing, I don't know, well, I guess for the sky, the motion of the sky, things like what direction does the Earth rotate, clockwise or counterclockwise from where you are, what might be something that they could figure out. But basically, I'd like them to look at the motions, the pattern, finding the pattern in the sky, that we see certain stars, like where we are anyway, Cassiopeia, Big Dipper, Little Dipper, they're always up no matter what time of night you're out. When I was in New Mexico, I realized how much I used Cassiopeia to find things in the sky because it wasn't there. And so depending on where you are, you can see different things in the sky and what are those patterns. I know I can't ask my students to travel. It would be nice, but we can't. But if they can get an idea of how the movement in the sky is related to where you are on the Earth, and just the seasons and the time of night and things like that, and how all of that comes back to place, that would be really nice. In BC, we have our First Nations principles of learning is very strong in our schools, and coming back to the idea of place-based learning and learning from the environment and all of that, this is one way that I could bring that into an online course. So that's also something that I would like to work with.
I was gonna ask, and it looks like Marcia has also said it in the chat, if maybe part of the culminating, because I know that we don't just want it to be, like, I think you were saying in your email that you don't just want it to be a series of kind of dry questions that they answer, but what about if, and this is just a stab at an idea that could just lead elsewhere. What if part of the culminating was looking back at their journal entries and then seeing like sort of the entire theme of their journal entries about their sky observations, and then asking a question as a starter, like, are there any patterns that you notice within your journal entries? Or alternatively, what questions come up? What could be really fun is if you draw it back to curiosity so that it keeps them wondering about things. You could maybe do a questions harvest, that they, or have them do that, where either they look at all of their different pages and see what questions they've come up with over time, or if they're trying to analyze about patterns and see if there are patterns or aren't patterns, then it could lead to more questions about, what, and also what tools might they use from here to keep looking to answer some of those questions, or to keep investigating, because then it kind of brings back all of the tools that they've been learning in nature journaling. And I don't know, that could just go to some really interesting places. Or maybe a challenging question where it's like, let's try figuring out what to do with this, bonus points if it's wrong, because then that means that we experimented. I don't know. I don't know if any of this is sparking anything with you, but just a few ideas off the bat. But I want to hear more from you. What's on your mind?
I like those ideas, looking for patterns in your journal entries. I was thinking of trying to do something with storytelling, in terms of First Nations education that way. what sort of stories can you tell based on from your observations about how the sky works, and can be as creative or scientific as you like. So that's something I was thinking about. Interested in hearing other ideas.
Would you mind if I ask you a question? Does your I know the school is all online, but does it have does the school have like a working elder or anything like that that's within your system?
We cover all of BC,
Mhm.
so I mean,
Yeah,
even our own school district has 14 different First Nations. So
yeah,
all
that's
of
what
BC has a couple hundred.
I was
Um,
thinking like it might be kind of cool for them to do all the observations, and then if they were able to find somebody within the community of wherever they are, the Indigenous community, and bring it back and make the connections to, for Indigenous ways of knowing, sort of, and then see how their observations from, you know, the two different types of sciences, which are very overlapping, but then getting them to have those two different perspectives might be kind of cool. And then they would have to reach out, and it could become a community thing as well. Reaching out. Does that sort of make sense? I don't know if I made myself very clear with that.
yeah, I do something another optional assignment in my physics 11 is with simple machines and how they've been used traditionally. And so there they do have to go out and connect with somebody. I find
Oh,
that one isn't done very often because it is difficult for some of our students to actually get in contact with people in the different First Nations. So, I mean, I
yeah, but
like the idea. It would be
yeah,
nice, but
it might be a cool idea if you had a couple of different culminating activities. So if you had one where folks were able to make that connection and then be able to sort of bring it all together back that way, but then have another option for the folks who find that it's difficult because of where they're residing to make those connections, right? And then have a separate one as well, so they can kind of pick between one or two, or have a broader um culminating activity with sort of like little pillars of how they can bring that focus in. But I really like your idea of bringing it back to place, and I think that would be really interesting, is to sort of ground it within the people that are in those spaces or who were in those spaces, including themselves, right? Which would be really interesting. So I would kind of like the couple of those different ideas there.
Also, to add to that, that's one of also the reasons why I really, really like your idea about sit spot. Not only is sit spot very place based, but then also by being in the same place over and over again, it gets easier to see how the sky changes because you've got the same frame when you sit down. That tree next to your sit spot's still there, that skyline is still right there, but the sky changed. And then it allows your students to really look and center themselves, because like you said, they're from all over. Some of them are going to be from the city where they've got light pollution, and they might have to look for their indicator stars to see how much or how little they can see that night. Some students will be out from the countryside where they can see an entire map in the sky, and it's individual to each of those, because that city kid may not necessarily be able to see what the kid out in the country sees, and vice versa. And so by letting it be individual to them instead of off some curricula that may not completely apply to everybody because it comes from a textbook, um, I really like that strength of your program about the place-basedness of it.
thank you.
I think that the idea of a nature journal also as tying these things together, sort of linking into what Billy Joe is talking about with with a sit spot, is, let's say you are looking at the moon over a period of time, or if you're looking at what, say, the Big Dipper does in the course of one night, right? The nature journal allows you um, to record what it was at this time, what it is at this other time. So you're able to time travel in the nature journal in a way that our memories can't really effectively hold. Marcia was talking about using the Big Dipper as a clock, and that is a really useful way of thinking about the sort of the Big Dipper and sort of motion in the sky, is to at time at time 0, draw the North Star and the Big Dipper and the angle that they are. And then at time 1, draw it again, time 2, draw it again. Is it moving the same amount in the around that clock in the same time interval? If so, right, then that's really useful to it. If not, there's something really interesting going on there. They'll find that it is moving the same amount. So does it come back to at the same time 24 hours later? Is it back to time 0, or that time 0 location? Just sort of like, is it a 24-hour clock, or is it a little bit more? Is it a little bit less? That would be interesting to see. And that's something that you could map and journal. And then think to yourself, then if it is coming back to that position, or how much is it going to move in 1 hour? So what I always like to do is when I'm sleeping outdoors, is I look up at the Big Dipper and I notice its position, and then I say to myself, all right, sun rises at this time. Halfway through the night, I would expect it to be here. Then 3/4 of the way of the night, I'm expecting it to be here. Just before sunrise, I'm expecting, what is the change in that angle of where what is it, Merak and Doobie are pointing to the to the North Star. So you use that. You can then sort of figure out, like, oh, it's almost dawn. I like when I wake up if I'm uncomfortable on my Insulite pad, kind of like, oh, I've got, just go back to sleep. It's like the night's hardly started here, or it's like, oh, it's almost sunrise. That might be a fun thing. But that, as Billy Joe was saying, that recording that same phenomenon over time also kind of helps you sort of be in that place. Another thing that is in sense of place is using the stars to find your latitude. And that's a really, really fun thing to do. Like, because then the stars above you tie you into exactly your place on the planet. So the easiest way to do this, if you're doing it with we've looked at how on equinoxes we can figure out our latitudes, but it's really easy any night of the year, if you can see your north or your south celestial pole. So if you can find the North Star and then go from the horizon, 1 potato, 2 potato, 3 potato, 4 potatoes, the number of degrees that the North Star is high in the sky is your latitude, right? Because imagine that you were on the pole, it would be directly over your head, 90 degrees. If you're on the equator, it would be right on the horizon. And so as you go up to the pole, that the number of degrees that is up in the sky, it gives you your latitude. So if you've got kids all over Canada, and wouldn't it be fun if they have any friends who don't live in Canada, and you can get them to count that same thing? The more that you can kind of get data points all over the world, what is the relationship between what city does that person live in, get that information, and how many degrees are they measuring that the North Star is up in the sky? You could have kids themselves figure out the relationship between latitude and the height of the North Star. Or if you're in the southern hemisphere, finding the south celestial pole is much, much more difficult. You have to kind of line several constellations up. There's no one star that is sitting there. But if you find that point, how many degrees is that up? That would be really interesting. And if they want, they can call me, and I'll measure my North Star for them so I can be a data point a little bit further south for you. So this brings us into looking at stars and constellations. Anybody out there, what ideas do you have about other ways of recording and documenting and playing with stars and constellations in our nature journals? We are very, very curious.
Before we continue with that, I just also wanted to note a quick time check and make sure that the time is still good for Steph and everybody else as well, because it's almost 2, or it's almost. That's all. I just wanted to be respectful of everybody's time and especially Steph's.
Thank you very much, Avea. Why don't we let's do this. Let's do a rapid fire round of anybody who's got, we haven't talked about it yet, or you didn't see it on the list, things that you really want to make sure are on Steph's radar. I'm going to throw one thing up here. And if you've seen some of our other discussions, and that is solstices and equinoxes are Nature Journal Gold. So this is a the height of this is a playground near my house. This is the height and path of the sun on our winter solstice. This is orange is the equinoxes. This blue is what the sun is doing on our summer solstice. So this is down here. This is our June solstice, and then this is our winter solstice down here. That's a ton of fun, and it's a very journalable thing. Anybody else? Do you have other high percentage sky stuff for our journals? I'm going over to the gallery view to see if anybody's raising their paw. So with the eclipse, oh man, right? We've got, if you are under the path of so solar eclipses are hard because you have to be under the path of the solar eclipse in order for to get that to work for you. The lunar eclipses, though, anytime there's a lunar eclipse, everybody on the dark side of the planet gets to see that lunar eclipse. So everybody gets to play with a lunar eclipse. But for a solar eclipse, if you have ways of recording it in your journal, that's going to be really important. Here is a so these are notes of an annular eclipse in Texas, looking at the shape of the sun as that cookie got nibbled. I made a projector with a telescope and projected images of the sun down onto my journal, and then also have just little notes about little patterns of what I'm seeing underneath the trees. So that's another possibility. Does anybody have any other favorite phenomena or thoughts about how you might connect journaling with?
I really like, once again, Steph's thing about indicator stars as a way of seeing how much brightness you have, or the sky, like indicator, sorry, also, I might be using the word indicator star wrong, but like not only stars to show your position, but then also Okay, here's a random example. As a city kid, and I think I've talked about this before, when I look up in the sky and I'm able to see how many stars of the Big or Little Dipper I can see, then it sometimes will give me an idea about how clear the night is or how much light pollution there is. Can I see the double star very well, or can I not? Can I see more than just 3 of the Little Dipper stars? If I can, it's a good night. If I can't, then eh. And then from there, questioning about why I can or cannot see more. What kind of night is it that I can't? Is it the weather? Is it the light pollution? Is it smog? And that leads to more questions. And then also thinking about where's the nearest place to go where you can see more. Because then it kind of goes beyond astronomy then in that case, and it leads, and it also like it continues on to place-based, which in turn, depending on where you live and how you live, it might also bring up ideas about environmental justice. So I like that and the trajectory of where that question can go. When I see Steph saying indicator stars on our form, that's what makes me think of.
Really good thought. I like that because that's a very measurable thing. I was first thinking like, how like we can't count the number of stars up there, but your idea of how many stars in the Little Dipper can I see, and using the Little Dipper as an indicator system, that is genius. I love it. Love it.
Yeah, for a really big city, you probably wouldn't see any, so you might need to use the Big Dipper instead. But
yeah. Right. Yeah, like is it so dark that you have to jump over to the biggie? Can you see and Avea also mentioned there's one of the stars in the handle of the Big Dipper is actually the double stars Mizar and Alcor. And so can you see both of those? So there's a little there's an eye test or a sky clarity test waiting right there.
Oh, I didn't think about that. It could also be a site of eyesight stuff.
Mm-hmm.
My son and I have been recently trying to look through our window at the moon, and we have a very narrow view of the moon through our room. But it's interesting to see how that little sliver of the moon that we're able to see changes each night. And we've got my binoculars set up to a video cam tripod, and it's hard to also adjust them properly. But then we're able to see how many of the craters we can see and stuff. But sorry, that's kind of an aside. But if you've only got a little sliver of window where you can see the sky, then noticing the time at which you can see things can be very interesting as well. See time change over time in a weird way. I see Billie Joe raising her hand.
I just got, this is a little side note sort of thing, but I just got thinking about the power of language. And I wonder how that could play into your culminating project at the end in terms of place, and wondering how language of astronomy throughout place, right, could contribute into this as well, right? So depending on where folks are living, this could bring in some of your indigenous connections as well as language that's used for all the different patterns or names of things throughout the world. So this could be a really interesting and sort of powerful way to bring it back in a culminating connection piece as well, is the power of language and how that impacts different things that we're looking at. So something kind of interesting.
I like how you're connecting this into other curriculum areas. That's great. All of these are ideas, and we'd love to check in with you later, Steph, to find out what you ended up using, and as you start doing this, to report back in with us about what seem to be the really high percentage, most useful activities, or the nature journaling activities that seem to make the biggest impact on people and are the most interesting to them.
Mm-hmm.
So
I can definitely do that.
As you look at the ideas which we've shared and bounced around here, are there any that are, do you have any sort of thoughts or comments or feedback for us about our time together today.
Well, I think it was really helpful, just getting out different ideas. And like I said earlier, I'm glad this is being recorded, so I can come back and watch parts of it again where I need to. And then just the sharing of ideas is really helpful, and yeah, going to think of how to put it all back together. And I like the ideas of language and place, and tying it in with people who have been here for a long time versus people who are settlers and things like that. So it does, it does allow for that more of a cross-curricular exercise that way. Yeah, that was really helpful. I appreciate it.
I'm glad you prompted us to think about these things a little bit more articulately. There's a lot of really neat stuff that we can do out there. I'm now thinking about, like, I'm really would love to kind of geek out on what sort of Billy Joe's idea about, like, with human behavior. So it turns out that when you statistically look at it, there's no difference between a full moon and a half moon and a quarter moon and a new moon in how busy emergency rooms are, right? You know, here in the United States, our emergency rooms are really busy after 4th of July, or times that people get drunk and play with fireworks. So that makes for busy emergency rooms. But you think about the wildlife out there. The wildlife is responding to light levels, or I would imagine that they would. And so, like, you know, that makes I'm really kind of like now buzzing with Billy Joe's idea, like, how could I test this? Like here's an easy one. They've got these listening stations out that can identify birds by sound, and so they can actually track some bird migration things by these systems. I wonder if bird migration is like, how does bird migration, how is it affected by light levels? I don't know. Like, could you use those listening stations to also listen for other levels of animal noises? I So that's something that I'm going to, my brain is going to be spinning on that for a while. I'm really grateful to my amazing co-hosts, Billy Joe Reed and Avea Moore. Avea, I love that you brought us back to really thinking about what is going to be most useful for Steph. There's a lot of really interesting ideas. So thank you also, Laura, for your thoughts and ideas about what can we do to so much of our sort of how we're piecing together things in astronomy is by making observations of what we see at this moment and trying to tell a story through time. What are things that we can do to set up experiments to also to think about how this world works? It's been a really, really lively discussion. Steph, we are grateful to you for sharing all of those resources that'll give some of us other ideas about things that we can do, and for prompting us to have this deeper conversation. I'm going to suggest to everybody, because a lot of really useful ideas dropped up in the chat, this would be a great time to go to the chat and download
The area of the three dots has changed. So instead of looking down where you type, you have to look up at the top of wherever the chat window is, and then there should be three dots there, I believe.
Yeah. And yep, and it says save chat. Yep, that's right. That's where it is now. I was looking down on the bottom. I was looking in the wrong place. Like, wait a minute, I can't do this anymore. But that's right. You can save the chat, folks, if you want some of these ideas in the conversation that was in the chat. We appreciate everybody who shared there, and also here in our lively discussion. the the stars above are a wonderful thing for us to explore in our nature journals, and want to encourage people to get out, get creative, see how you might be able to explore and document things in your own nature journal. You don't have to wait for an eclipse or an equinox to come knocking at your door. Again, those kids that where we documented the motion of the the moon over time, and then they figured out the direction of the spin of the Earth and the direction of the orbit of the moon. Those are fifth graders. Those were fifth graders. So we can do this stuff, and it's fun. Just to give you an example of another thing that like I'm trying to figure out, like in some of my journals, I've got some notes of like, if you see the crescent moon and it's making a little C like this, the sun is over here. But the further that when the sun is way over, when the moon is on one part of the sky and the and I'm seeing the sun on the other, as I try to connect those with the way my brain intuitively draws a line across the sky, it's not working out for the way I think the geometry should work. So I'm trying now to kind of wrap my head around how can I understand better what's going on there. The more we look on anything, we're going to run into phenomena that we don't understand. And for a lot of those, you can dig in more and get more clues and figure stuff out, as those fifth graders did. For other phenomena, we just sometimes we realize like this is something that I really don't understand. We can reach out to other people. Some of that stuff, some other people will have also investigated, and we can take advantage of what they've discovered. For other phenomena, it's stuff that we don't know yet, or perhaps never will. But being curious and trying to look to the natural world to help us solve these puzzles is a wonderful way to train us to think critically and to have so much more fun, just what we call deep geeking out. So thank you all for being here, for participating, and I look forward to seeing you all again. Until we meet again next time, stay curious, and let's go out and play in this big and amazing world, maybe even tonight. Thank you, everybody.
Thank you. Thank you.
Take care.